I'm gonna present a model-driven approach to automate development of communication channels for IoT applications from Roshan Rathod. Uh, so I'm assuming everyone knows what IoT is, so I'm just gonna jump to this diagram which shows a typical IoT application or a system. So there are IoT devices which send some information to the server or the data collector, which gets all the data, processes it and sends it to the data consumers, the end users. So it can be in infographics or any other format. So we see a problem which try to work on and come up with a solution for that. So the problem here is the number of IoT platforms that are available right now, and the variety of protocols makes it really challenging and difficult for IoT application development of IoT applications. So there are Android, there's iOS, there's Raspberry Pi. If you develop something in Android, same code cannot be used in iOS because of programming language difference. You need to select a protocol to work with the system, MQTT, HTTP, co-op, based on your system performance you need or it's a constrained network. You need to make sure the data encryption is there for the security of the data, and the developers always need the customization so that they can modify their RT application based on the user requirements. Uh, so a typical IoT example, like smoke detector system, get some data, detect smoke, says the room temperature is 90 degrees Fahrenheit, the temperature is so and so, the time of event is so and so. Raspberry Pi is connected to the device and to the internet. It gets the data from the device, sends it to the web server using MQTT protocol in this case. The web server is responsible to process the data, convert it into a human readable format, and give it to the user. So we know what's common here. The communication part, like the system, it would be a smoke detector system or a doorbell system or any other IoT system. But the communication will always be the same. The device will send some data to the server, and the communication part is always going to be common. The system might be different. So let's talk about the challenges that are faced by developers during developing these IoT communication channels. Uh, the variety of platforms, like we discussed, Android, iOS. You working with a new system, do you develop Android or iOS? If you develop both, the the time increases. You need to put in extra effort to write code for both languages. Uh, if you already have an IoT system, say working on Android, if you want to do iOS, you have to write everything from the scratch. So uh, then the complexity of putting different protocols. You select MQTT or co-op. If you have constrained network, then co-op. If you want a better communication, asynchronous communication, better performance MQTT. But you need to check if your system that you're using, the environment has some restrictions or not based on the performance and security. Also, implementing these protocols is really complex than it looks because the code to write this protocol is not easy. Uh, Developers often understand the need for security, but they lack the expertise to create a really secure IoT application or any other application in fact. The complexity is really high when trying to write a secure uh, application because it also affects the performance and scalability. So it's really important that it's implemented correctly. Now there are many libraries available out there, like for Android there's Retrofit, for Java there's Spring Boot. Now these libraries do certain tasks that makes the things really easier, like HTTP post is handled by these libraries. Now instead of writing everything from scratch, you can use these libraries, which makes your task easier. Not all developers are aware of these, so that becomes a problem. And also, even if they write everything from scratch, is it implemented correctly? Is it buggy? So there are many factors that are involved which could affect the system overall. Again, if you don't write the code in an organized manner, when you try to make changes in future for new feature requests, it becomes really difficult to incorporate those changes because if you make changes in one place, you need to make changes in many other places. That's not a very efficient design. Now IoTCom is based off it's basically trying to improve on these challenges, and it just abstracts the common part here, that's the communication part, and tries to build the communication channel for the developers, so it makes things easier, because the IoT system, the application that they have, what their application performs, the task will be always performed by that application that's specific to their system, that we cannot write, but the communication part is the same, so that is something that could be reduced, the overhead of writing that could be reduced. So we provide a completely customizable framework. Um, so it basically accepts some user input, asks some parameters, and gives some options, takes the template code base, replaces the data that's given by the user, and gives them the generated file. So this is how it looks like. It takes, let's take the smoke detector system example. We created this in Yeoman. It's really good for generating code. So it takes us the user or the developer for input that would be sent from the device to the server, say temperature and time of the run. Once that's entered, we provide them the programming languages, Java or Python. They select the language, then we give a list of protocols available. Select the protocol. We ask the server address where the data needs to be sent, so we handle the communication, and we ask the secret key to encrypt the data that is being sent. Once the information is given, the file is generated. This is just a part of file just to show how it would look like. So the API URL is the server address, and that's where the information will be sent. The variable that the user just entered, that's the post data which will be posted to the server address. This is how the encryption looks like. We're using AES 128 encryption because its performance is really good as compared to others, which we have explained in the paper. Uh, this uses the secret key provided by the user, so the data can be decrypted only by the user because only he has secret key. So how we try to address the challenges? We try to uh, create the communication channel completely on our own. Like the programming languages, we allow the user to select programming language protocols based on their current environment. So if they have a system that works on Android and they want to create a system that works on iOS, they can build their own own code for their specific IoT application completely, but will reduce the overhead of writing the communication channel. We will provide that communication channel instead of them writing that communication channel. So it reduces the overhead, helps the developer to get rid of all the complexities such as encryption, decryption, makes the communication secure, provides them the latest code standards, libraries, uh, also gives them the flexibility to play around with data. They're using their own server, they're not using any third party server. Everything is sent to their server directly, so they can trust that everything is safe. We do not have any control over that code. Also, the code is organized, so if you want to make changes in future, it's really in one place, because we've used um, really good design patterns so that it becomes, the maintenance becomes really easier. So what's different here? We have I'll just tell you the related work. AWS IoT is one of the other IoT platform that's available right now. So AWS IoT is allows user to connect their IoT devices to the Amazon's admin portal. So basically using third-party server, it the only security feature is authentication and authorization, which means once the user authorizes a certain IoT device, Amazon just authenticates if it's the same device, and only then it allows the communication. So basically, the data is not encrypted while it's being sent from the device to the server. So any intruder can get the data and it can be compromised. Again, you're using Amazon's third-party server, and it's a portal which means that you don't have any control over data. You don't have any APIs, so it's you cannot customize it at all. No infographics, no nothing is possible. Lumix is almost the same. The only big difference here is that Uh, they provide APIs to the developers so that they can play around with the data, and they set up the device on the cloud and provide API. So users can play around with data, and they only support one protocol, that's MQTT, and even with Amazon it is MQTT. And again, the data is not encrypted over here too. So in IoTCom, we developed this based off the features that are not being offered by these IoT platforms. So we provide a completely customizable framework. You use your own server instead of a third-party server. You have flexibility to use any available protocols to integrate into your existing system or create a new system and get rid of the hassle to write the communication part. All the encryption standard is already handled by the communication framework. You don't need to worry about encryption, don't need to worry about port standards. New feature requests will be easy because the code is organized very well. It can be maintained easily on their own server. Now, in future, we want to add more programming languages so that all the platforms are covered. That's the future of this project. But that's not really easy. So we trying to build an open source community right now for so the developers themselves can contribute the templates which can be used with the system, so other developers can use the same templates to incorporate in their own system. So that's about it. Thank you.